1.5 Quadratic equations. Fill in the blanks so that the resulting statement is true. An equation that can be written in the general form of ax squared plus bx plus c is equal to 0, where a is not equal to 0, is called a quadratic equation. The zero product principle states that if a times b is 0, then a or b equals 0, basically, right? Either a equals 0 or b equals 0. The real solution of ax squared plus bx plus c equals 0 corresponds to the x-intercept. I don't see a graph right now, but basically, if you had an x and y graph like this, let's say it dipped below and above, right? You have to remember that this equals actually your y, right? So you're really saying where y is equal to 0, right? We'll get more into this later about graphing and stuff, but basically you're saying, well, ax squared plus bx plus c equals to 0, where y is equal to 0, right? So y is equal to 0 all along the x-axis, right? So it's not, if it's above the x-axis, then y would be positive, and if it's below the x-axis, then y would be negative. But right along the axis, this x-axis, right? That's the x-axis. Y is equal to 0. It's not positive. It's not negative. It's 0. I mean, the opposite would be true for y. So this is the y-axis, right? So you would say everything this direction would be, well, x is equal to negative, and everything in this direction, well, x is going to be a positive. And we'll go into more of that later, but this is basically the gist of it. So really what they're saying is where y is equal to 0, this part right here, right? Y equal to 0, that's where it crosses the x-axis right there, right? So if you graphed it, that's what you're saying. They have it right there. Y is equal to ax squared plus bx plus c. So that has to do with your x-intercept. It's called an x-intercept because it's touching or crossing through the x-axis. So where it touches the x-axis, we call that the x-intercept. So hopefully that makes sense. Okay. So let's dive in and use the zero factor property. We're not going to test you over what the zero factor property definition is or anything like that, but you have to know enough terminology to realize when they're asking you to solve an equation through the zero factor property what it is they're asking you to do. So again, my recommendation is to always read the instructions before you answer a question so that you're familiar enough with the terminology that you can answer those questions. Because right now it's divided up kind of in an order and you have similar problems together, but on a test they might jump around and you might have 3 problems that look very similar or even identical, but they might ask you to do 2 or 3 different things with the same looking equation or expression, right? So unless you know enough of the terminology to know what they want you to do with that expression or with that equation, you may not be able to answer the question, even if you actually know how to do the algebra. So again, just always read your questions, make sure you get familiar with the terminology so that whenever you're forced to differentiate, you're able to do so effectively. Okay. So let's dive in. So example, use the factoring to solve the quadratic equation. Okay. So first step on this one is, well, first it's a quadratic because it has a second power, right? Next, we are going to break this apart because it's a simple trinomial, meaning it has a 1 leading coefficient. So take the square root of x squared, you get an x. It ends in a negative, right? So we know they're going to have opposite signs. A negative times a positive or a positive times a negative is a negative. And when you add it together, you end up with a negative 1, which means the stronger one must be negative. So you're looking for 2 numbers that you can multiply together to give you a 72, that if you add together would give you a negative 1, right? So again, negative 72, where the stronger one is negative, so you have a positive 1, negative 72, you have a positive 2, negative 36, you have a positive 3, negative 24, that's a 4 by the way. You have a positive 4, negative 18, you have a positive 6, negative 12, not quite. We have a positive 9, negative, skipped one, sorry. A positive 8, negative 9. I flipped the numbers temporarily. And that's good enough. Now, so we also want to know when we add them together, how do we get a negative 1? So this is the result of multiplication, right? And this is the result of addition. So this is the product, and this is the sum, right? The result of multiplication, the result of addition. Okay, so if we add these together, now most of you already know which ones. I'm actually just being thorough and writing everything down, but obviously that's not going to work, right? Positive 1 plus negative 72 is negative 71. That's not even close to negative 1, right? I do recommend, I mean, you're not a computer. You don't have to do every possible version of this. If you know it's not going to work, you don't feel compelled to write every different possibility down, right? So if you know the first few are not going to get anywhere close to 1, there's really no reason to write it down. Just kind of skip around a little bit if you want to, but that might take a little more experience. But again, don't feel compelled to write every different possibility. If you kind of know where you're aiming for, and you know it's not going to work for the first few, don't feel compelled to write it down. It's okay. You can skip around. You're not a computer. Use your intuition reasonably. So now we're up to plus 6 plus negative 12. You add it together, you get a negative 6. Still not there. And we say we have a plus 8 plus negative 9 equals negative 1. And that is the 1, right? So when we multiply it together, we get the negative 72. And when we add it together, we get a negative 1. Okay, so we got our two numbers here. So I'm going to put a positive 8 and a negative 9. It is not important whether you put the x minus 9 first or the x plus 8. It doesn't matter. What does matter is if you put the positive 8 and the negative 9. So the negative is always going to go with the 9, the positive is always going to go with the 8. That part is important. Okay, so now that you have it factored out, according to the zero factor property, if the product of multiplying this factor and this factor together is 0, that would either mean the first one, right, either x plus 8, or the other one, x minus 9, is equal to 0. One of those must be true. Don't really have to put it in parentheses at this point. Okay, so I will solve for x. So that would give me x is equal to negative 8. And this over here will give you x is equal to positive 9. Now, obviously you can just look at these because these are simple ones and you can just flip the sign. That's true. Later on, whenever you have variables in front of these x's, though, the more complex ones, you might want to set it equal to x because you're going to get fractional answers sometimes. You're going to have to reduce. So just remember you are actually setting equal to 0. Just because later on when they get more complicated, you might actually have to write it out instead of just flipping the sign. And by setting equal 0, it might make it make more sense or make it easier to do the algebra later. Okay, but for right now, the easier ones, yeah, by all means, just flip the signs, and that'll give you your answers at the end. Okay, now, I don't write this enough, and I should. Technically, you want to write this in set notation to write the answer, and set notation is just a list. It's like, red, blue, green, vanilla, strawberry, chocolate. It's just a list, right? So order doesn't really matter in set notation. So I could have just as easily written this as 9 and negative 8 rather than negative 8 and 9. Sometimes orders matters, sometimes it doesn't. In the case of set notation, order does not matter. When in doubt, though, just put it in order. I mean, you're not going to get counted off if you put it in order when you don't have to, but you will get penalized if you don't put it in order when you do have to. So when in doubt, just put it in order, right? But again, just technically you don't have to. Okay, so let's try the next one. Same kind of step. First, this is a simple trinomial, so we're going to start with a couple of nice little parentheses there, equal to 0. Square root of x squared is x. It ends in a negative, so one's going to be positive, one's going to be negative, or vice versa. It works either way. So we're looking for two numbers that we get a negative 42 for, that if we add together, we'll get a negative 1. Negative 1. Okay, so we know that the stronger one is going to be negative, and the weaker one is going to be positive, right? Multiply this together, we get negative 42. We also have 2 times negative 21. We have 3 times negative 14. We have, so let's see, we're going to have a 6 times negative 7. And these are, of course, all equal to negative 42. You don't have to write as much as I'm writing. I'm just trying to write all the steps. You can skip steps or not write everything down. You'll know you're ready whenever you can get the correct answer without writing a step. That's fine. I will say this, though. I've had tons of students who skip steps, and they get the wrong answer. And then they'll try to do it mentally again, and they'll get the wrong answer, and they'll try to do it mentally again, and they'll still get the right answer, or the wrong answer. I mean, if you keep getting the wrong answer, and you're skipping writing steps, my recommendation is you need to write more steps. And I don't mean that disrespectfully, I mean that just realistically, right? So again, you'll know you can skip a step when you skip the step and you can still get the correct answer. If you can't get the correct answer, you probably need to write that step. You're not saving yourself any time or grief by getting the wrong answer repeatedly. So oftentimes, getting the correct answer, if you take your time and you get the correct answer very slowly and carefully, oftentimes it'll take you less time than you rushing through and getting the wrong answer 3, 4, 5, 6 times. I've seen it before. So again, it may seem counterintuitive, but if you rush through the math and you're constantly getting the wrong answers, it may behoove you to slow it down to go faster. And I get the fact that might be counterintuitive, but again, if you're making tons of careless mistakes, you would probably get through your homework faster and do it better by slowing down and being very careful and very meticulous. And then by doing it correctly the first try, it can actually take you less time. I'm actually, in real life, I rush through things. So to do math, I actually had to learn to slow things down and be much more careful. So you might have to do that as well. Okay, so the -7 is going to go on the right side, and the +6 is going to go on the left side, right? If you want to check your factoring, remember that you can just redistribute this and check your factoring. And if you're able to get back the original, then you probably factored correctly, right? So again, just don't forget that if it looks like you're making lots of mistakes on your factoring, you can check your factoring. So when you're tested on factoring, don't forget, you can check factoring. Okay, now at this point, we have we have x plus 6 multiplied by x minus 7 is equal to 0. Because these are two factors multiplied together to give you 0, we know that either x plus 6 is equal to 0 or x minus 7 is equal to 0. So what we would do to find that out, we would simply set them equal to 0 and solve. Okay, so -6, cancel, cancel. X is equal to -6. And we say plus 7, cancel, cancel. X is equal to 7. And just to be thorough, we're going to write it in set notation. Oops, set notation. Squiggle, 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 squiggle. Okay. Now, if I really wanted to make sure that this was correct, I could plug it back into my original equation and I could verify. It's important to know where you can check your work so that whenever you have a test or you have limited tries on something, not the homework, but maybe a test or a quiz, if you can get to the point where you can quickly get through it, you can go back and you can check your work and make sure you actually got the correct answers. So it's actually important to know where you can check your work. You can check your factoring like this, right there, by redistributing, and you can check all equations basically by plugging the answers back into the original. So don't be afraid to do that. All right, so, and by the way, if you're not checking your work because it takes too long, you're never going to get any faster until you practice. Okay.